All right. So we were right in the middle of doing a code walkthrough to implement this multiple token recognizer on multiple lines. And by the way, so what we'll do today is we will finish the code walkthrough for that example program from the book, the Java version of it. But now, and let me say then that just looking ahead, previews of coming attractions, has anyone checked the
really long.
Has anyone checked the program that's due Thursday?
We don't have anything to do on. It just says start.
Thursday's assignment is start
our project.
The project. Monday's assignment is that's when it's due.
Oh, so it's just.
So what I'm saying is that it's a milestone. This is the first. The next programming. The next assignment is the first milestone of the big project. There are 3 milestones. Okay, this will be the first one. So I emphasize that no late. I'm going to be very strict on this assignment, on collecting it right, on time, and making sure that so make sure that you allot enough time to do it, because and as we're going through this code, you might keep in mind here's what the next programming assignment is. It's to do this for your PEP 8 assembly language translator. Are you with me? So this is what we're doing. This is the first. I'm giving you the skeleton with this, with all of these techniques, of what you will have to do the lexical analyzer for the project, and that is the next assignment that's due Monday. And the assignment that's due Thursday is to start it. That means it's big. It's your first big milestone. Are you with me? So what we're going to do is we're going to go through this. We're going to finish doing the code walkthrough here. All these techniques that we're doing in the code walkthrough are directly applied to your project. And then what we'll do is, I'll actually show you. For the lexical analyzer, I'm going to give you the finite state machine. Now, let's review again. What are the 3 stages in a translation program? Lexical analyzer, parser, code generator. So the parser is, and normally for a HOL6 language, what is the lexical analyzer based on? Okay, multiple choice. It's either a grammar or a finite state machine. What's the lexical analyzer based on?
Finite state machine.
Finite state machine. And normally, when you translate an HOL6 language with a compiler, what is the parser based on? A grammar. But for our translation, because we're translating from assembly language, and that language is line-oriented and it's simple, we can use what for our parser for the second stage, a finite state machine also. Now, that finite state machine you're going to design for the parser.
Are we not designing the one?
The one for the lexical analyzer, I'm going to give it to you. So you see, in the same way that that this program is working off of a given finite state machine, your lexical analyzer, your tokenizer, will be based off of a finite state machine that I'm going to give you.
And that's what we're working on this week. Is that.
And that's what, and it's
And you're gonna give us a,
this little machine only has like 3 states.
Oh, okay.
But the one for the project will be same concept. It shouldn't be any different. It should just be.
Okay, yeah.
Okay. It's going to be.
Like 6 different.
We'll study it.
Great.
We'll look at it. Okay, but you'll have that. Okay, so I'm just giving this to you so that as we go through this, you can be thinking ahead. Think, oh, now how's this going to pan out? Okay, so that's previews of coming attractions, right? That's the trailer. Okay, so now let's move. Let's continue now. Then we started by looking at figures. We ended class last time looking at figure 7.31, the Java version of it. And we already have the user interface all done. And we did those examples. We did a demo last time. And do you remember at the end of class last time we were we had presented and we had looked at the implementation of the buffer. Remember that? You remember what 3 attributes were in the buffer?
Input.
The
An
in-string.
in buffer.
But what were the attributes of an in buffer? We have an in string, and what was the in string? That contained what?
The entire.
The entire text, all the lines, the whole thing. And then there was another attribute called line, and what it did is it took one line at a time. And then there was another attribute called the line index, which was the current position in the scan of the terminal characters. And remember, as we go through what
Every time we get a new line, we take it off.
we take it, yeah. So in string, whenever we get the next line, we pull the first line off of in string, and that becomes line, and then we delete that line from in string. So it's like we're gradually stripping off the lines from in string, and in string gets smaller and smaller and smaller. And what did we guarantee? The first thing we did whenever we got the string, the whole string to start with, what was the very first thing that we did? Concatenated with 2 consecutive inlines, new line characters. Okay, and that guaranteed that the last line would have length 0. And so, because we don't want, in order for the algorithm to work, it's required those 2 consecutive inlines, but we don't want to have to impose that constraint on the user. We don't want to have to tell the user, oh, in order for this to work, you got to put, that would be user unfriendly. So we'll guarantee it by appending that at the beginning of the when we first get the string to parse from the user in. Okay, so then at the very end of class last time, we looked at we see how in buffer gets new in buffer blah blah blah, and then we looked at the tokenizer, a little code bit of the tokenizer. And what does the tokenizer do? It says tokenizer T gets new what? Tokenizer, but then what did we give it?
In buffer.
In buffer. Now what is every object in Java? Every object in Java is a what? Yes, it's called a reference variable in Java terminology. Okay, but basically what it is, it's like a pointer. So therefore, and so what we said is that the tokenizer has a pointer to the buffer that got allocated in this action performed method. Right? And we had a picture of that up on the board last time. Okay, just to review. Okay, are we good? Now before we take a look at the rest of this code in action performed, let's look ahead a little bit to figure 7.30. This is the Java version of figure 7.30. Okay, and obviously what kind of diagram is this? It's a UML diagram, Unified Modeling Language, right? And what do you suppose that class up at the top, why do you suppose we call it a token?
That's abstract.
That's an abstract token, right? And what does an abstract token have? Does it have any attributes? Yes or no?
No.
No attributes. What methods does it have?
Get description.
Get description. And what does get description return?
String.
A string. Are you with me? So every concrete token that is a subclass of abstract token implements its own version of what? Get description. Are you with me? Now, do you remember? Now, where do you think this is going to come into play? You know, when we did the demo yesterday. What was the output?
We outputted what?
We outputted, we outputted what the token was.
It needs to say integer.
It needs to say that, yeah. You connect this with what we did? Okay. All right, okay, so that's good. Now, there's this particular class program has 4 concrete tokens. So, T identifier is obviously a token, so T for token, okay. So that's token identifier. And in addition to implementing its own get description, what does it have? What attribute does it have?
String.
Yeah, a string value, it's the attribute is called string value, and its type is capital S string. It's a Java string. Now, why should a identifier have? An identifier is a string of characters, right? So that's its value. Are you with me? Okay. And then what about? So that it has that attribute, and then there's an additional thing that it has. What's an additional thing that it has? It has a method called what?
Constructor.
Yeah, it's a constructor. And what type does it have?
String buffer.
Yeah, it has a one parameter called string, lowercase s string buffer of type uppercase s string buffer. Now, do you guys remember, some of you I think were in paradigms when we did Java. Do you remember the difference? I think, okay, so I'll put you on the spot here. Do you remember the difference between a Java string and between Java type string and Java type string buffer?
No.
Okay, well here, all right then, listen up. Because when the rest of you guys are in paradigms next time, I'll ask you this question. You should have remembered it. You don't remember this? Okay, string, here we go. String and string buffer. I know there's one, once I write this down you'll say, oh yeah. All right. String is, maybe you can answer me this question, mutable or immutable?
Mutable. Right? Immutable.
The difference between a string and string buffer is that string is immutable, whereas string buffer is what? Mutable.
Meaning string buffer is more like an array?
No. Yeah, now what does mutable mean?
Or you can like...
Technically, it can be changed.
It can be changed.
But can't we like concatenate?
Actually, we did this, no, wait. We remember mutable versus immutable from data structures.
Yeah.
Yeah.
That's what I'm doing.
Yeah, oh yeah, good. But what it means is it can be changed or cannot be changed. Okay, so but the immutable one is what? Cannot be changed, right?
Why can't strings be changed?
Because they're immutable.
For strings. I thought we would concatenate strings.
But notice what we did. That's a really good question. Here, let me finish this. Can be changed. Look. That is a really good question. How did we concatenate? In fact, let's go back and look.
Changed, they can just be set to something else.
Yeah, where did we do that concatenation? Where was
It's in
it?
the first one.
It's in a
Where-
in buffer.
Where you concatenating them.
In the buffer, was it the buffer one?
It's our in string.
There.
Here, yeah, let's go back to here to this 7.27. It says in string gets what? String plus, no. It does not say append and then to in string. Do you see what I mean? Did you see the difference?
Yeah.
So basically what it does is it takes the original string and it
Just set to something else.
concatenates, it makes a copy of the original string, and then it concatenates those to the copy, and then it replaces it with the, yeah?
Okay.
So if it was a string buffer, could you say string gets string plus string or something like that?
Well, yeah, string buffer, okay, string buffer is another whole class, and we'll see. The reason we're doing this is because what we're going to do is we're going to use the string buffer, because as we are collecting it's for efficiency, as we are collecting the characters one at a time, because we scan these characters one at a time, we want to have just that one thing, and we want to be able to change it. Just stick it on the end, stick it on the end. We don't want to have to copy, it's for efficiency. We don't want to have to make a new copy with that stuck at the end and then have that be the new copy. Do you see what I mean? Now, does everybody, this is really good Java stuff to know. Yeah? Okay, so let's go back to then our, here. Okay, so that's the story behind T-identifier. Now let's take a look at t integer. So t integer, that's a token integer. So what attribute does an integer token have? An int value. What is its type? Int. So you remember we're going to be converting the value to an integer value. So that token is going to store that integer value in it. Are you with me? And then what method does it have?
T integer.
Which is a
Constructor.
constructor. And what are we going to give the constructor? Some integer value. And what do you suppose that constructor is going to do?
Convert it to an integer?
No. It's
set
given.
it
It's going to set its attribute to that. Yeah. And does the empty token have any attributes? Nope. But so there it is. And does the one more thing. What if there's an error?
Invalid.
Invalid. Are we good? Does everybody see how that works? Okay, so I'll show you the code in a minute for that, but let's just keep this in mind. There's an abstract token, right? And then there's four concrete ones. And then what we'll do is we'll use polymorphic dispatch. Why are we doing this? So we can use polymorphic dispatch to process, all of our tokens. Okay, so now let's go back to the action performed method and do a little code walkthrough and see how this all works. Okay, so first of all, as we said before, we allocate a new buffer called nBuffer. We allocate a new tokenizer called T, and the reason we use T is so we can it's nice and brief. We can say T dot, Okay, so our tokenizer T gets new tokenizer, and that tokenizer, oh, by the way, I noticed when I was reviewing yesterday's lecture, I said something that wasn't quite accurate. I said that there were other attributes in the tokenizer other than T, and when I looked at it, I realized actually T is the only attribute in the tokenizer. I mean, sorry, not T. I think it was B. Remember, B was the buffer. I think that only had. I was looking at it. It only has one attribute. So anyway, I was mistaken. Gave a little inaccurate description yesterday. Okay, so now what local variable do we have here after the tokenizer?
Abstract token.
An abstract token. Are you with me? And what do you suppose this abstract token is going to do? It's going to get a value. It's going to get the value from. All right. And then the very first thing. Okay. So those are the local variables. And then what's the very first thing we do before we get into the while loop? nBuffer.getLine. And now we have one while loop. That outer while loop. And what is that? How many times does that outer while loop execute?
At least once. Oh no, that's not right.
Twice.
Well, I'm not asking you. Yeah, that was a hard question to answer. Okay, it executes once for each what in the in source?
Character.
The outer loop. Yeah, that was a little incorrect. And that was the point of the question. How many times? What is the outer loop? How many times does the outer loop execute? Once for each what of the input? Are there two loops? Are there two loops in here?
Yeah.
It's
There's
each
a
line,
do
right?
There's a while, that's the outer loop, and then what do we have inside the outer loop?
Do loop.
We have a do loop. So we have an outer while loop and we have an inner do loop. Now let me ask it again. How many times does the outer do loop execute? Once for each what? Those of you out there, you're not off the hook.
Is it one for each line?
One for each line is correct. And then the do loop inside that executes one for each what?
Character.
No, answer is not character.
Token.
Yes.
Oh, yes.
Once for each token. What is a token?
String of characters.
It's a group of what? What kind of character?
Alphabet.
And
Tr-
terminal.
It's a group of, it's a string of terminal characters that have
Meaning.
meaning as a group. All right, so now it's really important to see how the loops work. So let's review it again. The outer while loop executes one for each what? Line. Are you with me? Then the inner loop, the do loop, executes one for each what? Token. Now, okay, but when we get a token, the tokenizer for an individual token, that will execute one for each what? One for each character.
Right.
So now do you see how those three levels of abstraction, processing abstraction, are you with me on this? It's really important to have that idea in your mind, because you don't want to have extraneous loops all over the place. These loops are 3 nested loops in the execution sequence. Outer loop, one for each line, inner loop, once for each token, and then within the token, one for each terminal character scanned. Are you with me? So you have to have, yeah, we have to understand that structure, okay? So let's take a look at the outer loop. It says while what? In buffer dot what? Input remains. Okay, and you remember we saw how that was implemented before. Input remains, right? That's if there's input remains in the whole thing, all right? So if input remains, okay, so long as input remains, what do? We start what? The do loop, okay? So now that do loop is do while. So before we take a look at the body of the loop, it's do while what? While what? Not.
It's not empty.
Now, actually here, no, I'm sorry, we shouldn't go in that sequence. It's do. So now let's do the loop. Okay, so now let's do the first thing we do in the do loop. A token. Now what is a token? That's that abstract token that we said before. And what does it get?
The token.
T. So what does that tell you about T, a tokenizer? It must have a what? A method named get token. And what must that method named get token do? What is its type? No, what does it return?
Token.
It returns a token. Yes, it returns an abstract token, which will be one of those specific ones.
Right.
So do you see after it does a token, it gets t.get token, that will have that token, right? And then what will it do? And then what do we do? System.out. What?
Print line.
Print line. Oh shoot.
Should we print out?
You want to print out?
Yeah, I thought I had gone through and made everything printf. I'm going to have to modify that a little bit. Yeah, I'm gonna have to update that because I had this idea of always doing printf. Yeah, but anyway, so anyway, that's fine. Print line, but what does it print?
The description.
The description of the discussed.
A token dot
Get description.
get description. So what does that get description output? It's
A string.
yeah,
Whatever.
in a string dot equals and then whatever its value is, right? Does everybody see that? And how do we know? How does it know which one to execute? It's polymorphic dispatch. All right. Each one does its own. We don't have to say if it's this kind of token, do this. Else if it's this kind of token, do this. Else if it's. Are you with me? That's all polymorphic dispatch. Isn't this cool? And now you guys, we've got that a token has a value. And so now what's the test for the loop? While what?
The token's not.
Not a token instance of T empty. Now, does everybody understand that that's the Java way of checking the dynamic type. You remember in C++,
Okay.
every object has 2 types of what? Static type and a dynamic type. What is the static type of?
Abstract.
The static type is abstract token, and the dynamic type would be either T integer or T identifier. Are you with me? Because dynamic, that's what changes. It morphs. So it's polymorphic. Okay. So so this is the way to check the dynamic type. You do this in Java by this keyword instance of. So while not a token instance of T empty, all right. So if T empty, if it's ever once we get to the empty token, what will happen to this loop?
Stops.
We'll break out of it. And furthermore, what will happen to this loop if it's an instance of T invalid.
Break out.
It'll also break out of
And
it.
we go to the next line.
And we go to the next line. So you remember how that behavior, remember how we noted that behavior last time in our demo? Is this cool? I think this is way neat. This is very clean code, I think. All right, and so look, so that inner loop goes for each token. The only way we can break it, when we break out of that do loop, what have we gotten, what have we processed? We have processed one whole line. So what's the thing that we do after that loop? We do in-buffer dot get line. So that gets the next line. Are you with me? And that takes us up to the while in-buffer dot input remains. Now think about that.
What does input remains check? If there is something that we haven't even looked at yet?
Doesn't it make sure the length is?
The length is, right, the length is 0. So when we do this in-buffer dot get line, that will get the last empty line.
Does that check if our line is equal to 0?
That bash n,
Yeah.
okay.
If that is the line that we get with in-buffer get line?
Yes, then what will be left, then that will be stripped off of
In string.
in-string, and in-string will be empty.
Okay.
So when we check the length of in-string,
Okay.
it will be empty.
But say we get the last line of actual content, then we will still go through this loop one more time.
Yeah, actually, that's a really good point. This code is designed to work correctly if you have an empty line not just within your assembly language program.
Somewhere, it'll still work.
Yes. Did you notice that in the demo we had some empty we had a string and then we had some empty lines and we had some other. Those empty lines do not trigger the end of the whole thing, because you want to be able to have the user have empty lines in the source code, right? That'll just be, yeah. Oh, so there's lots going on here. This design has, I mean, there's a lot of details, and this is a very clean design that works all the way we want it to work in all cases. So is everybody clear on this code right here? So now the next thing we need to do is we need to see how to implement an abstract class and a subclass in Java. Okay, and it's all very straightforward. So here is a file atoken.java, okay, and the little documentation there. And so here's in Java, how do you make an abstract class? You start it with the word what? Abstract. Do you remember how to do that in C++? What does that correspond to?
Is it tiny?
Oh, come on. Oh, shoot.
In C++?
Yeah, in C++. How did we do an abstract class in C++?
Isn't it like protected? Or like
No. Protected is an access.
Yeah, that's like public or private.
Yeah, public, private, or protected. Yeah, that's an access.
Is it more than just having a class inherited? Was there
But what about the class that's at the top of the hierarchy tree? How did you notate that in C++?
it needed,
Come on.
Oh, double colons?
No, double. Okay, now let's review that. The double colon is the fully qualified name. You have, like, if there is a method that you want to implement and you want to say, oh, that's the method for this class. So it's the class name : :
is it the
So that fully qualifies the name. You know, like the name of
Single colon is
it.
inheritance.
Say it again.
A single colon?
A single colon is inheritance. But that's right. So that's good. Okay, you remember that. Okay, but wait. But what I'm saying is, how did you notate that a class was abstract
pure
in C?
virtual, right?
Yes. Now, pure virtual.
Ben was like, imaginary.
Yes, it is pure virtual. And so what do? In the beginning, you say what?
Pure virtual.
No, you don't say pure
You
virtual.
set it to 0 at some point.
Yeah, well, the notation was that equals 0
Equals 0.
at the end, and then
You say
virtual. Yeah.
Virtual.
Okay, so you virtual and then equals 0. Okay. Actually, yeah. Okay. Is everybody good? Okay. When we did those. That was a good review. Okay, so now, well, no, I mean, it's really good. You know, here's the thing, the way your neurons work, you get away from something and then you remember it like this and review it, that cements, I mean, physically, those connections, those neural connections now are stronger now than they were before. That literally, I'm telling you, this is the way you learn and remember. You go back and you, yeah? Physiologically, those connections just got made. Okay, anyway, so now in Java we say abstract. Okay, so abstract public class a token. Are you with me? And then remember we said that it had one attribute in the UML diagram. Sorry, not one attribute. No attributes. One.
Just a method.
Yeah, just a method. One operation. Okay, so public abstract. And then string is the type that it returns, and get description. All right? Are we good with that? And then in a separate file, these are all in separate files. A separate file for the abstract class. Here's a separate file, tempty.java. Okay? And now, how do you suppose, well, have we done inheritance yet in Java?
No.
We did in paradigms.
Oh, we did in paradigms, that's what I meant.
Extends.
Extends. All right. So that corresponds to what in C++?
The colon.
Colon.
Single colon. Okay, so, yeah, is everybody good? Okay, so public class tempty extends a token. And then public string get description. Okay, this is all very straightforward. Yeah, we're implementing get description, right? And what does this do? And what does this return? It returns a type string, right? And so it returns, quote, empty token. Yeah, and here's our invalid. Public class T invalid extends a token. Get description, return syntax error. Remember we had an example of syntax error coming out in our program. And here is our T integer. Now remember, what attribute did a T integer have? An int value. So there it is, private int value. Public class T integer extends a token. Yeah, inherits from a token. All right. And what does the constructor do? Public T integer int I. What does it do? It sets its attribute to the value that we give it. Are you with me? And then what is how does it implement get description?
Integer equals.
Yeah, integer equals. Oh, and here is our.
Is there something?
Oh, yeah. This is not printing. This is not. Yeah, this is not print. This is not a.
Oh, that's interesting.
No, because what it's doing is it's returning a string.
Right. Oh, so it's going to generate the string.
It's going to generate the string using that same format. This is why it's really good to use printf. It's because it gets you used to doing this string.format. Does everybody see what this is doing? String.format constructs a string in the same way that printf prints it. But this generates the string. We're passing strings around.
So it'll print it just like that. It's called printf.
When it actually returns it, it'll
Yeah.
be integer equals whatever our value.
Yes.
But how come there's so many spaces? Just so that this.
Did you notice how they all lined up? Did you notice how they all lined up?
Token names line up, yeah.
I mean, it was because it was like one was integer and the other one was identifier, but they all lined up on the right.
Gotcha.
Little,
That was a little tricky there.
yeah. Had to do a few little test cases to make them all line up and stick an extra space in there, but I think it's really visually nice to have those equals and have them all line up. Are we good? Okay, and here is T identifier. Its attribute is string value and its type is string. All right. Oh, and look, what do we give it?
String buffer,
We give it a string buffer.
which is mutable.
Oh, wait a minute. This is public T identifier. Okay, so that is. Oh, yes. Only we don't say string value gets string buffer. Why not? Why can't we say string value gets string buffer?
String value is a string.
Because the types are different. Are you with me?
Yes.
Their types are
We have
different.
to actually.
So we actually have to construct it.
Is that like casting them?
No. It's
You're actually constructing
you're actually constructing it. Because look, do you see that string value is like it's an object? And what are all objects?
Reference.
Reference variables, so you have to new them. Is everybody clear on that? Okay. And then get description. So everybody.
Is that just another constructor for string that will take a string buffer and make it a string?
Yes, it's a constructor. Yes, it's a constructor for string, and there is a constructor for string that if you give it a string buffer, it will do that. Yeah, that's a good observation. Is everybody good? See, here's the thing, you guys. Once you've learned C++ and you've done object-oriented programming, learning Java, I mean, you got the concepts down, polymorphism, all that stuff. Learning Java is just like falling off a log. We don't even have you don't even have to take a Java course. We can just do it here, right?
It's really easy to like look up anything.
Yeah, yeah. Plus, there's no garbage collection is automatic. So you don't have to do any deletes and worry about memory leaks.
No destructure.
Yeah, so it's so easy. It's so much easier. I mean, just to go this way instead of going the other way. All right, and now there's a special little utility class, okay? Util stands for utility. And here I have a public static Boolean isDigit. Does everybody see how that works? You just returns true if it's a digit between 0 and 9. And then here is alpha. So if it's alpha, what is it if is alpha? It's between lowercase and A and Z or uppercase A and Z. Yeah? Are we good? And do you remember the finite state machine that we had? What were those states? Start, ident, sign, integer, and now we add what? Stop. Are we good? That's in its own file. So you use NetBeans IDE to keep track of all those files, and they'll be all listed for you. And you know, there's real resistance to doing this without an IDE, but with an IDE, it's really nice.
How do you do it without an IDE?
You just have to keep track of them all yourself.
You just put them in the right folder.
Put them in the folders, however you want to do them. If you want to do them in separate folders or whatever, yeah.
Do we have the resources to like compile a program and then just have an executable?
Java, not with Java. The whole idea of Java is that you need the Java virtual machine.
Oh, right. Okay.
But I mean, your executable does run on the Java virtual machine. I mean, that's what this is.
Right.
All those classes.
Like,
so what would happen is
somewhere like we wouldn't have to open NetBeans and run this file. Is there a way
correct.
to run it without that?
Java on the command line.
Oh, command line.
You know,
okay.
Yeah. Okay, now you guys comes the big one. Now comes Tokenizer. Okay, so now check out Tokenizer. And here, I'll repeat what I said before, that the only attribute is the buffer. Are you with me? And we already looked at the constructor. It just sets the buffer, the reference to the buffer that we did before. Now, here is the main program of the Tokenizer. The main method is getToken. You remember what getToken returns?
Token.
An abstract token. Are you with me here? So let's take a look at the variables. These are local variables within getToken. The first one is nextChar of type char, because now this one is going to loop through. See here, let's look ahead here. It's do, and then what? Da-da-da, da-da-da, while, da-da-da. But this is just what?
Our last assignment, really.
Yeah, this is just the direct code implementation of, yeah. So we know how this is going to work. Are you with me? One for each one, okay? So this is just the internet. So look, so we have char is, did we even use nextChar?
Yeah, we did.
Maybe.
Yeah, we needed to.
We did.
Okay, but anyway, that's the idea. And now check this out. Local string value gets new string buffer initialized to empty string. See, we have, because we don't know if we're going to be, here's the thing, we don't know if we're going to be, if what we're going to be scanning is going to be an identifier. We don't know if what we're scanning is going to be an integer. We don't know. So we have these local variables. We have a local string value. We have a local int value that's initialized to 0. We have a sign, our int sign, that's initialized to +1. you know, just like we did before. And what do we start off? We have a local what?
State.
Abstract token that's initialized to the what?
Abstracted.
No.
To the empty.
To the empty token. Are you with me? And then we have our state variable. Initialized to what? Start. Is everybody good? And now here it is. The rest is basically what we already know how to do. Okay? What do? We say next char gets what?
B advanced input.
B, so what was that B? That was that buffer pointing out to the, yeah? And whenever an advanced input returns a char, right? Is everybody with me? So next char gets that. And now how do we do it here with our direct code technique? What do? Switch state in case E start. Now, so case S start, if we're in the start state, what do we say? If, just go through this code.
If it's a letter.
Yeah, if it's a letter, what do we do? Now, here's how do we do with the buffer. Local string value dot what? Append.
The letter.
Now there is mutable.
Right. We were just
Append.
at the end of it.
Append, that means it's mutable. We're not saying it gets this appended, you know, concatenated. Does everybody see that that's a mutable operation? And we're doing it because it's a buffer and it's, okay? And if that's true, then, and furthermore, we append next char, and then state gets what? S dot S ident. So the next state will be the ident state. Yeah, if you go back and look at the finite state machine. Else if next char is hyphen, then what? Sign gets -1, state gets S dot S sign. Else if next char is plus. Now that sign gets +1 was actually, might not have been necessary because did I initialize the sign?
Yeah.
Yeah, but I think, see, Java makes you, I think Java made me do that.
Initialize.
Yeah, I think it made me initialize it. I don't remember for sure.
Weird, Java's weird with for loops like that too.
Yeah, so I mean, you sometimes they make you initialize stuff even if you don't really need to.
Yeah.
But anyway. And then state gets us the sign. And else if, now check this out. Else if what? Util, that was our utility class, dot isDigit. Notice that this util is a class, it's not an object. Whereas if you're saying local string value dot append, that local string value is an object, whereas util is a class. Okay, so that's an interesting difference between those method calls. So else if util dot isDigit next char, then what? Local int value gets what? We know, we've done this before. Yeah? Stop, da-da-da. Else if, and the else if next char is, now check this out. Else if next char is what? The new line character. Then what?
Oh, stop.
Stop.
Okay.
Are you with me? Okay. Else if next char is what?
Is
Empty.
not
Not equal to a space, then what? A token gets what?
invalid.
New T invalid.
Weird. So if it's not any of those things,
If it's not any of those
Not
things
space.
and it's not a space,
then it's
an error.
okay.
But what happens if it is a space?
Then we just read to the next one.
Then it'll stay.
Then none of those happened,
So it'll stay in that state.
and we stay in that state.
Yeah.
Yeah?
Good deal.
Is this cool? And now here's the end of it. There's a case S ident, what? Now we're in the ident state, right? So what? If util dot is alpha next char, or what? Is digit, because now that we've got the letter or, now that it starts with the letter, it could be a what? A letter or a digit. Now, okay, so what happens? Local string dot value dot append next char, yeah. Else what? You guys, back up. Because what if it was a hyphen? I'm sorry, yeah, what if it was a hyphen?
Because then it's different.
You need that hyphen to start,
Yeah.
it might be like a -47 with no space in between. Are you with me? Else b dot backup input, a token gets new T identifier, local string value. Now what was the type of local string value? That was a what? String buffer. So that converts it, that constructor, right? Converts it into, okay. So a token gets new T identifier, local string value, and state gets what?
Stop.
Stop.
Stop. And then sign, what do we have? Sign gets new T identifier, local string value, and state gets what?
Stop.
Stop. And then sign, what do we have?
Then you can just have digits.
Yeah, if util.isDigit, and here there's converting it to the int value, just like we did before. And furthermore, state gets what? Integer. Else what?
That's
Invalid.
Yeah. You just look at the state and you say, what happens if I'm in this state and I get this? Well, you just code it direct code. You just boom, boom. Simplify, yeah? And sorry, I lied. I thought that was the last one. This is the last slide. And what if we're in the integer state?
Didn't we just do that one?
No. That was the sign.
Because if it's plus or minus.
I just saw the first line.
Because, okay, so if is digit, what do? 10 times plus, yeah? Are we good? We've done that before. And then else what?
back up.
Back up. Because what if there's a letter there? Well, it could be the start letter of the identifier that's coming up next. Are you with me? Back up in. A token gets what? Now, a token gets new what? T integer, and what value do we give it? Sign times, because we converted that. Sign could be +1 or -1, right? And then stop, boom, 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 boom. And then while what? Its state is not stop and
It's not.
not a token instance of T invalid. And then what do we return? A token. Ha! Woo-woo! Okay, you now have everything you need to know to do the first milestone of your project, which is due a week from yesterday. Are we good?
Yeah.
Yes.
Excellente. See you Thursday.